Good. So thanks for the opportunity to talk today. Given it's day 4, and there must be lots of tired bodies, I thought I'd start with something controversial. So I think this is the biggest battery in Europe right now. 6 megawatts, 10 megawatt hours. It's all about size. We know it's all about size. I don't think it will be the biggest battery for very long. I think Ireland will steal that title by the end of the year with an installation by AES. But nevertheless, I think we're bathing in the glory for at least 5 minutes or the next 3 weeks or whatever it turns out to be. And what you can see on the picture on the right is what we promised some of our customers and some residents in the east of England what it would look like. And you can see on the left, we delivered on that promise. This is the fully installed site, and we kind of lived up to our promise as to what it would look like. So that's the installed site. So what I'd like to do is just really try and give you a brief introduction to the status of kind of storage in the UK, and then tell you a bit more about what we're trying to do with this particular project. And really, to cut a long story short, you're not going to hear me speak a great deal about battery technologies. You're certainly not going to hear me kind of take a view on one technology over another technology, because for us, this project is all about trying to understand the commercials and fundamentally the revenue earning potential in order to try and bring storage to a place where it's competitive. So we'll set out and we'll show you what it looked like in terms of who was involved in the installation. How did we contract for the device, and we'll tell you very clearly how we're approaching the market, and how we're doing that in a way which is fully approved and sits within all the current kind of legal frameworks and so on. And you'll see a few early results in terms of us delivering a variety of services, and I'll finish by talking about the business case. And that will probably bring me back to some questions around kind of, how things are moving kind of worldwide, and how do you capture that last little bit of revenue that's going to make it a positive case. So I won't dwell on this slide because we talked about this early on. I'll leave it for you to kind of look up on your way through, or obviously kind of review slides after the event, but essentially we're one of the 2 biggest distribution network operators in the UK, and we serve about 8 million customers. Now this I think is going to be of more interest to you. So this is a map that we put together with the other distribution operators in the UK, and gives you a really clear picture of what the status of storage is in the UK. I think essentially, I kind of I talked about it when we did the introduction. I think that the headline is that the UK right now is going down a kind of a market-led approach. So on the one hand, there's a reasonable amount of innovation projects, and the vast majority of the projects shown on this slide have received innovation funding from either the energy regulator, or they've received innovation funding from the Department for Industry, for want of a better word. But once the innovation has finished, essentially it's kind of left to the market for storage to stand on its own 2 feet, and either successfully win in the capacity mechanism, or successfully win against demand response, or successfully win against a distribution network wanting to kind of simply upgrade a line. And so I think it's fair to say that we don't have an equivalent of the California mandate. We don't have an equivalent of what we heard about in South Korea yesterday. We don't have, as in the case with Turner, we don't have an approved allowance with our economic regulator to start installing storage. So at this stage, it's kind of an innovation environment, lots of learning taking place. Doesn't have quite that same stimulus that you're seeing in other countries. Apologies, it's a slightly strange map. It misses Southern Ireland off for all sorts of kind of complicated reasons as to how we're regulated, but actually there's quite a lot of activity that you heard about yesterday in Ireland, and I think it's Cool Routes just on the border, is it, that AES are, I think AES are probably going to steal our title and put in the biggest installation by the end of the year, and which will concentrate on the transmission flows across, I think, Northern and Southern Ireland. So, what is it that we were doing with this project? So we have, we're one of the innovation projects that's been awarded funding from the energy regulator in the UK, who are called Ofgem. And really, we won the funding on the basis that we were going to try and demonstrate a energy storage facility which didn't operate in one of those industry silos. So it wasn't going to be simply trying to earn money out of frequency response. It wasn't simply going to try and compete with a network upgrade on the distribution network. It wasn't simply going to try and arbitrage wholesale prices. It was going to try and do a bit of everything in order to make the business case. And because that's our fundamental belief. Our fundamental belief is that any one of these income streams is not enough. You need to be able to kind of put them all together. And so that's exactly what we're doing. You can see on the right hand side, we did, I think we started out very, very technology agnostic. We didn't mandate batteries. I don't think we certainly didn't mandate a type of battery. We have installed lithium-ion batteries, and you'll see, and those are, and it's been a turnkey solution from S&C Electric. And the other interesting feature I think about this one, which does add a bit of additional value to the other innovation projects taking place in the UK, is that this was the substation that had the need and therefore needed the storage is actually in a residential area. So we took on a slightly different challenge. The containerised solutions weren't an option for us. It had to look nice, and it also had to be flood resilient. So when you look at this, and certainly when you come to look at cost later, do bear in mind this is your flood resilient, aesthetic, pretty, fully planning permission compliant energy storage facility. So it's been an interesting challenge to get there, but we have. So the first and the most fundamental thing that the battery needs to do, or the energy storage device needs to do, is it needs to support what we need it to do. And to give you the kind of context to this, Leighton Buzzard in the east of England, or kind of in the verging on the Midlands, is a 33 kV to 11 kV substation. So that's what we call one of our primary substations. It in turn is fed by two parallel 33 kV overhead lines from an upstream 132 to 33 kV substation. And it's essentially, in order, those two lines are the immediate constraint. Those two lines are the ones that are running out of puff. After that, actually, the transformers on site are also running out of puff. So the traditional solution to this would have been to have put in a third circuit, and then actually probably in quick succession soon after that to have put a third transformer at the site as well. That third circuit could not have been an overhead line due to planning restrictions. Therefore, it would have been an underground. Underground costs more than overhead, and actually we were looking at something like a 20-kilometre stretch of underground cable. So actually the case that we made, and we had to make this in two different directions, we had to make a case to the economic regulator, we also had to make a case to the planning authorities, actually that this was both, or could eventually, certainly with the stimulus funding, it's cost competitive, and secondly, it's actually less disruption, and it's quicker to do. So you don't have the disruption of digging 20 kilometres of roads or fields to get the cable in, and it's actually a darn sight quicker. So this has taken place, this is kind of essentially for 12 months from end to end, from a greenfield site to what you see there. In terms of how we partnered with it, and we kind of deliberately tried to show this as a pyramid, because I think it's what we're trying to say with that is I think it's an interesting time, because we did go out to tender looking for a turnkey supplier. We chose S&C Electric as our turnkey supplier, and you'll see on this S&C in turn have subcontracted Wilcox and Samsung for both the batteries and the control system. But actually, I think we're getting to a place where actually that you may not need to do that. It's not. I don't think we're there quite yet, but I can see on the horizon a point at which a distribution network operator would genuinely have the choice of going with a turnkey solution or deciding to put the parts together itself, kind of best of breed of each of the different parts. I think it's really interesting to see companies like Unicast, a company like Greensmith and so on, who are kind of just picking one of these parts of the value chain and saying we are going to become specialists in that low-level control system, for example. We're going to become specialists. We'll be battery agnostic, but we're going to become specialists in how to make the best use out of a battery stack. So I think it's an interesting time, really interesting time. The other really important thing about this is that we worked with a company called AMT Cybex, who are now part of Capgemini, in order to develop a scheduling system. So, the last thing we wanted to do was to construct this, to demonstrate it, and so on, but to kind of be optimizing and forecasting on the back of a piece of paper or the back of an envelope, and then sending a man to site to throw the switch. That just didn't seem like a sensible investment. So, we argued the case, and we got an additional investment from the regulator as part of the innovation funding to actually build a piece of software with CGI, which essentially takes market information and helps you to develop a schedule, decide what you're going to do with the battery at each moment in time. Once you've decided what you're doing, you then download that schedule to the battery, and essentially it then does what it needs to do. It has a control room override, which we don't expect to use, or we know the consequence. Put it this way: we know the consequences of using that control room override, because the consequences of using that control room override are that somebody like National Grid would declare that we've missed an event, and we would be into kind of penalties with them. So we accept that, but it does make the system end to end absolutely kind of replicatable and ready to use. And then a really important part about this is how we then kind of present ourselves to the market. So the other real fundamental principle about the project is that, again, we're not necessarily taking a view on whether a distribution network operator should own the storage device, whether we should use our kind of capabilities in contracting, our size essentially, to kind of get good pricing, maybe lead the construction, then hand it over to another operator, or essentially whether to just simply give a piece of land or kind of strike a deal which kind of says we'll give you the land, and we'll pay a certain price for the services. Please, somebody bring a storage device into being on that location for us. So what we're trying to do is collect numbers and facts and figures and financials throughout the project, and put them into any one of those different business models and allow you to do the same thing. So we have published some kind of business model templates and spreadsheets, which are available on our website that you can begin to kind of play some games with. But what I said on this particular occasion, we are essentially the owners of that, and we then have a number of different relationships. So first of all, the first relationship that we need is with an energy supplier. In that case, it's an energy supplier called Smartest Energy. So it's really important to understand that all of the energy going into the battery and out of the battery is metered. So physical meters there. We're also measuring we're sub-metering our ancillaries. So this is all entirely traceable. This is not being presented as part of our overall system losses. It's all entirely traceable. And in particular, the round-trip efficiency is being settled in the wholesale market completely transparently, and Smartest Energy are representing us there. Now, Smartest Energy will also we'll have a variety of different relationships with them. So from time to time, we will be saying to them, we want to charge now, how much is it going to cost, and we want to discharge then, how much is it going to cost. At other periods, over the trial period, we will say to them, guys, it's yours, use it how you like. And so they will be trying to balance up their own portfolio with the wholesale market, and what you might call arbitrage. Secondly, we have a relationship with a company called Kiwi Power, who are a demand-side aggregator. So they are already accredited with the GB System Operator National Grid for reserve services, and they are representing us in two ways. They're representing us into the short-term operating reserve or the store market, and secondly, they're representing us in or acting as our agent for frequency response as well. So we've agreed frequency response pricing with National Grid, and we're looking to kind of we're looking to schedule the commissioning test for that, and we hope that we'll get the commissioning test done by the end of May. But it's really, really important stuff, because actually this this will be the first form of storage since the hydroelectric power plants in the UK that have essentially reached a pricing agreement with National Grid and get paid for frequency response. So it's a really kind of exciting development, and we believe again that we're the first battery in the UK to be earning kind of any kind of money. It's really important to say down the bottom right hand corner there's a number of advisors that are helping us in this capacity. So Imperial College is one of those advisors, and POIRI Management Consulting do a lot of work on kind of energy regulation and really helping. Newcastle University have helped us design some of the forecasting and scheduling algorithms, and Swan Barton is essentially a guy called Anthony Price, who some of you will probably know. He's worked on both client side and vendor side of many storage kind of deals in the past. So where have we got to? So I think two themes over the next two slides of where we are right now. So we've kind of been up and running for kind of a quarter now, or kind of maybe about 4 months. We had some opening ceremonies and cut the ribbon in December. And I think two themes have come out of this. I think the next slide will show you what we've done in terms of services that have been delivered. We've definitely had some learning experience from the commissioning process, and I think some of the themes have come up. Some of the themes have come up in discussion over the last few days around matching battery technologies with power converter technologies and so on. So I think everything passed its factory acceptance test. Everything passed a factory acceptance test to IEC standards, to the standards you expect them to. I think my two learning points are, number one, I think it is possible to get lulled into a full sense of security, particularly when you look at those kind of IEC standards and so on, and you see lots of requirements to suppress any unwanted emissions by 50 dBs, 60 dBs and so on. It's staggering numbers. It's factor of a million, you name it. But actually, when the job of a device is to take 6 megawatts of DC, chop it up and reconstruct it as a sine wave, and when you crunch the numbers, actually 6 megawatts, even down by however many dBs, it can actually be volts. We get lulled into a full sense of security that we must be talking millivolts here, or microamps, or so on. But actually we're not. We are talking real volts. And I think the second aspect that I've personally learned from this as well is that I think, again, putting together a system of this size, the power conversion system, again, whose job it is to chop up a DC signal, chop it up at in the kilohertz range, and then put it back together again as a sine wave. Again, interesting that I'm not sure there are many other templates or many other applications where you're doing that in the kilohertz range, and yet you also have cable runs of tens of meters in some cases. So I think it's been, we're working through the challenges of the short story. We've had to go back and put some revised earthing in place. We're having to put a bit of additional suppression in as well. But I think these are, to some extent, these are also some of the experiences that other people have talked about. So just beginning to draw to a close, because I know I'll get looked at in a moment. What we've tried to show you there is what we've done so far in terms of providing services. So first of all, we provided service to ourselves, or stood ready, let's say, on 24 days on which those overhead lines could potentially have breached their capacity if a fault had occurred on one of those lines. So in practice, we were fault-free over that time, but we knew that we were also secure had there been a fault on the overhead line. Frequency response, like I said, we're looking to get that commissioned with National Grid at the end of this month. Another really important thing, though, is that we have earned some money from the triad mechanism in the UK. Not sure how many people are familiar with that, but it's essentially kind of trying to avoid the top 3 days of peak consumption in the UK, and National Grid put the large energy consumers under that obligation, or kind of expose them to penalties. That includes a kind of an aggregator, let's say, like Smartest Energy. So Smartest then pass on that benefit to us. If we can help them avoid their triad penalties, we get paid for it, and that's in fact what's happened. So we hit one of the 3. We were unfortunately out for some kind of ongoing commissioning with the other ones, but we hit one of 3, and that was, it was a reasonable amount of money. And then finally, we've been available for 225 hours of store, not yet been dispatched, but again that's again beginning to flow into the bank account. And then finally, so what does this look like in terms of a long-term value proposition? And again, this is, hopefully a trademark of this particular project, that we try and be as open with you as we possibly can around how we think we will get from where we are today to value. And what you see in those 2 bars on the left-hand side, the 5.1 is 5.1 million. That is the cost of the conventional reinforcement that would have been required, which I talked about earlier, in terms of a third circuit and eventually a transformer. The headline cost of this project, as awarded by the regulator, is the red bar, 16.8 million. But it's really important to say there's a whole bunch of things in there that we're doing that you only need to do once. You only need to design a scheduling software system once, and then it's available for everybody to buy worldwide. There's a whole bunch of other obligations, like doing speeches like this, that kind of are bundled into that. So, the headline comparison that you should come away with is 11.4 million for flood resilient, pretty installation at 2012 prices, which is when the procurement took place. So it's really the 11.4 that's fighting the 5.1. So we've made an assumption that technology costs will come down. We don't think it's a Herculean assumption at all. The 2.6 comes from the revenue streams that I've talked about on previous slides. The thing that will really turn it, and actually at that point you get to a point where you're kind of beginning to compete. The thing that will really make this become actually cost beneficial is if you can kind of somehow get some reward for the fact that there's a social good to this as well. So the fact that if there's more storage, if there's more flexibility on the system, even if it's hidden behind distribution substations, we should be able to avoid having to build additional peaking plant or refurbish peaking plant that's coming to the end of its life. And that's the bit that's tough to get hold of. We can't monetize it right now. There is a capacity mechanism that's kicked off in the UK, but it's not really suitable for storage right now. It's including nuclear as well, which is interesting. So that's the purple part is the tough bit, to cut a long story short. And so where I stand today is I think we're trying to make it cost neutral. It won't be cost beneficial. So let me complete with kind of just wrapping up to say, hopefully I've given you a flavour of what we think is a realistic challenge that we've taken on, like I just said, to be to get it to a point where it might be cost neutral in future. It will need to be cost neutral. It will need to, as it currently stands in the UK, it will need to kind of pass an economic regulation test, and essentially kind of things in the UK right now being kind of left to the market. So we don't have our equivalent of the California mandate. We don't have an allowance to build more of these right now with the regulator like Turner does, unless we make that case to them based on economics. And really, just to say, we're learning some fascinating things from doing this. There's stuff which you learn by doing this, which you would not have thought about, and you can't do it without, or you can't learn it without doing it. And just to give you one final example of that is to understand that as we pay our bill with Smartest Energy, we pay, when we import and charge the battery, part of our bill with the energy supplier Smartest Energy actually pays our part of the nationwide feed-in tariffs and renewable obligation certificates and so on, which are socialised across everybody's bills in the UK. What's then interesting is that when we then discharge, that then heads off to somebody's home to actually, run the washing machine or, or boil a kettle. That individual householder pays that all over again. They pay a second contribution to renewable obligations and kind of low carbon levies, let's say. So you just pick up some really interesting things like this. It's around the margins. It's not going to be the killer. It's not going to be the thing that makes storage kind of come alive and suddenly economic. But there's some really interesting stuff around the margins that you pick up that could well could really just help nudge things in the right direction if it got sorted out. So thank you for listening.